In this example, we want to graph a piecewise defined function. And this piecewise function appears to have three pieces, so we will be graphing a portion of three different functions. So we'll start with the first piece, which is right here, negative 2x plus 3. Now remember, g of x here is basically the same as writing y. So our first function is really y equals negative 2x plus 3. So that's my first piece. And this happens to be a line. So the way I recommend that you begin with graphing piecewise functions, always do them in pencil with a good eraser, because we're going to go ahead and graph this entire line, y equals negative 2x plus 3, and then we'll come back and we will erase the portion of the line that we do not need. So this is a line with a y-intercept of positive 3, and my slope, there it is, positive 3. My slope is negative 2. So just a little reminder regarding slope. When we write the slope is negative 2, we can think of that as negative 2 over 1. And slope is the change in the y values divided by the change in the x values. So a change in y of negative 2 would mean that we would be going down 2, and then a change of x of positive 1 would mean we would be going right 1. So from our y-intercept, we will count down 2 and right 1, and that would get us another coordinate, and we can keep going down 2 and right 1, and you could repeat that over and over again. But remember, another way of writing a slope of negative 2 would be writing positive 2 divided by negative 1. That's also equivalent to a slope of negative 2. So in this case, a positive 2 change in y would mean we were going up 2, and then the negative 1 would mean a change in x that would cause us to go left 1. So starting at that y-intercept, we could also go up 2 and left 1 to get another coordinate here. That's in the second quadrant, and we could continue if I had more room, up 2, left 1, something like that. So this would be the entire line. I would want you to use a straight edge at home, and that would be y equals 2x plus 3. However, we don't want the entire line. We have a domain here, x is less than or equal to 0. That's telling me the part of the line that I want to keep, essentially. So think about taking some scissors, and we are wanting to cut this line at 0, x equals 0. So if I go to x equals 0, my cut point, sometimes we call this my cut point would be here at 0, 3, because that's the point where x is equal to 0. So I'm going to call that my cut point. I'm going to cut the line, and then I'm going to keep the line, the portion of the line where the x values are less than or equal to 0. And that would mean I want to keep the portion of the line that lies to the left of x equals 0. So if I get my eraser out, that means I'm going to be erasing, there we go, we're going to erase the portion of the line here that is to the right of 0, and I'm going to keep the portion of the line that is to the left of x equals 0. Then I'm also going to consider whether or not I should have an open or a closed dot here at x equals 0. And because the inequality is x is less than or equal to 0, that means I'm going to include that point, so that's going to require a solid dot. Next, we'll move on to the second piece that we're wanting to graph, which is y equals the square root of x plus 3. Now this piece requires that I know what a square root of x graph looks like. So I consider that my parent function. So my parent function essentially is y equals the square root of x, and then the plus 3, because it lies outside of the square root, that's going to cause us to shift up 3. So if I just start by thinking about what a square root of x graph looks like, then I'll easily be able to shift that graph up 3. So the square root of 0 is 0, the square root of 1 is 1, and the next nice number, which is a nice perfect square, would be 4, and the square root of 4 is 2. So this is the graph of the parent function. This is essentially y equals the square root of x. And then I will just take each of these points and I will shift them all up 3. So let me do this on our grid here. So the point that used to be at 0, 0, if it shifts up 3, it's actually going to overlap with the end point of our line, which will be 0, 3. The point that used to be here at 1, 1 shifts up 1, 2, 3 and moves up here to the point 1, 4. And then lastly, our point that used to be here at 4, 2 shifts up 3 and becomes this point here, which is 4, 5. So right now, again, I'm graphing the entire square root of x plus 3 graph, which would be this graph here. And now we're going to go in and we will pay attention to the domain and we will cut this curve and erase the portion that we don't want. So this inequality here says we want all of the x values in between 0 and 4. So we're really going to have essentially 2 cut points, if you can imagine. So we have a cut point here at x equals 0 and another cut point here at x equals 4. And we want to keep all of the graph that lies in between these 2 coordinates. So getting out my eraser, that means I will be erasing any portion of the graph that lies outside. So I'm erasing this part of the graph. That was where x was bigger than 4. And incidentally, there isn't a portion of this graph that is actually less than 0. So there's nothing to erase on the left-hand side. Now you'll notice when we look at these inequalities here, both of these inequalities are less than symbols. They're not less than or equal to. So we do not want to include 0 or 4. So on the right endpoint, I'll get my eraser out here again, and I will erase this right endpoint so that I can make it a clear open dot so that I do not include x equals 4. However, on the left endpoint right here, remember, on the line, it was already a solid dot. It was included from the earlier inequality, x is less than or equal to 0. So that is going to remain a closed dot. So let me get my eraser and come back in here and erase and clear that up again. So from the line, it was already a closed dot, even though on the square root function, it was an open dot. If you can imagine, again, if it was open on one, but then the next one overlaps and closes it, it will remain a closed dot. So we are going to include that point on our graph. And lastly, we'll look at the last piece, which is right here, the absolute value of x minus 6 minus 2. So I'm going to label that as my third piece. Y equals the absolute value of x minus 6 minus 2. So once again, we have a new parent function. The parent function here is y equals the absolute value of x, which hopefully you remember that is a V shape, typically 0, 0, 1, 1, 2, 2, and then negative 1, 1, negative 2, 2 to get that nice V shape for the absolute value of x. And then we have x minus 6 in the absolute value. So that is going to be a shift to the right, shift right 6, and then minus 2 is going to be a shift down 2. So essentially that vertex is going right 6, down 2. So 6 comma negative 2 is my vertex, and then there has not been a stretch or a compression, so this V is going to open up. Therefore, from that vertex, I can go ahead and plot the left-hand branch, if you will, of the V. And even though my grid ends, the other right-hand side would be important to include as well of the V. So something like that. I overshot a little bit. There's my V. That's the entire V. And now let's go and take a look at the domain. We'll find our cut point, and then we will erase the part of the graph that we don't need. So we want the values of x greater than or equal to 4. So let's go to x equals 4, and that's where I'm going to cut my graph. Let's try a pen there instead of a highlighter. So I'm going to cut the graph here at x equals 4. That happens to be the coordinate 4, 0 in this case. And I want to keep the portion of the graph where x is greater than or equal to 4. So that means I will want to keep the portion of the graph to the right of x equals 4, and I will be erasing the portion of the graph here that is to the left. So let me get my eraser out, and here I am, I'm erasing. And then we'll make the decision whether we should include 4 or not. So looking at the inequality, if x is greater than or equal to 4, then we do want to include that point. So that means we'll come in here and make that a solid dot so that we are including x equals 4.